Okay, ladies and gentlemen, so now we're going to use what we know about this theorem to answer this question. Okay, so we're going to start off and we're going to plot the line 3x plus y minus 15. Now, if I want to know where this line is, I can use some simple grade 9 mathematics and I can plug in 0 for x, which will give me the y-intercept, so it'll be y equals 15. So it's going to cross through a point up here, 0, 15, and it's going to, if I allow y to be 0, it's going to cross through a point 5, 0 down here. And those are 2 points on this particular line that I'm working with. Remember that this line is given by 3x plus y minus 15 equals 0, which means we know something about that line. We know that its normal is given by 3, 1. And we learned that the other day using the scalar equation of a line. This is A, this is B, so its normal is 3, 1. What we want to do is we want to find its distance from the point 8, 13. So if I come out here to 8, 13, it's going to be 8. 13's up here, so it's definitely going to be off the line. And I'm going to call this Q, and we'll call this 8, 13, as per the question. So what we're really after here is we're going to show this normal, the normal to the line. We're going to allow it to cross through P. Okay, there's the normal. And what we're after is we're going to use this concept that the projection of PQ onto N is going to be equal to PQ dot N over the magnitude of N. So that's what we need to do here. So we're going to allow PQ to be any point. Now remember, when we set this up, PQ was any sort of vector here. So I could, for all intents and purposes, use any point that's on the line, and I might as well use 0, 15. So for this particular example, I might as well use 0, 15. Takes me to Q. So if I need to come up with PQ, it's going to be equal to P to the origin plus origin to Q, which will be origin to Q minus origin to P. So OQ is going to be 8, 13. OP is 0, 15. So it's going to be 8, -2. So that is our vector PQ. We would like to know its projection onto N. That'll give us the shortest distance between Q and N. So we know that N was given by 3, 1. So therefore, PQ dot N is equal to 8, -2 dot 3, 1, which is 24, take away 2, which is 22. And we need to know the magnitude of N. The magnitude of N will be the square root of 3 squared plus 1 squared. So that'll equal the magnitude of square root 10. I think we have everything we need now to plug into this equation. So the projection, or the shortest distance, from Q to L is, or is equal to, PQ dot N over magnitude of N. So it's going to be 22 over the magnitude of N, which is going to be that number. And you can use your calculator and figure that out, or we could leave it like that. That's an exact answer. I'm perfectly happy with that answer. So that's how we would do this. Now, go back and remember when we chose PQ, I allowed P to be 0, 15. There's no reason why it had to be that point. It could have been any point on this line that you choose to discover. Let's say I had chosen it to be 0, 5. Then that would have been your new P. I'll call it P2 just so that people don't get confused. So it's going to be PQ here, and we would be looking for the projection of this vector onto N. Now, that would be perfectly fine. We would go through the same workings here. The only difference is instead of P being 0,5, when we work with this one, P would be, instead of P being, it wasn't 5 in this one, it was 0,15, sorry. Instead of P being 0,15, it would be 5,0, and you'd get the same answer. Anyway, guys, hope that helps. Work on your homework, and we'll see you on the next day.